Thank you, Astrid, for your time, and welcome to this, I'll say it's the 13th episode of the channel. We really appreciate your time. Can you just introduce yourself to the community, to the audience, and please just start your presentation. Thank you.
Yeah, sure. So I'm going to give you a short introduction, and then we'll go through the agenda, and I'll introduce the background that I have. I'm Astrid van der Laan. I currently work at Zutari as a principal computational designer. Been at Zutari now for about just under 3 years. So yeah, let's jump into it, and then I'll go through a bit more of my background and where I came from, and then we see from there. So we're going to go through computational design in industry, just industry awareness. So I'm sure this is probably something Bayo's touched on in a previous episode, but it's interesting to see, while working in computational design, what people that don't work in computational design think it is. And then I've developed a very simple analogy that we're going to go through. Then I've got a little bit of an introduction to computational design thinking and some of the, the brain work behind what we do. It's more how we think. Then I'll touch on computational design in infrastructure, and then specifically we're going to go through a very high-level example of Cody in bridges, followed by a Q&A. So let's shoot. So as I said, I'm Astrid. Key qualifications that I actually have a background in architecture, studied at Tukkies up here in Gauteng, as well as a postgraduate degree in information science. So I have combined what I studied in computer science, so software engineering, game design, programming, and I've combined that with architecture. So my industry experience is, I come from a background in instructional design before architecture, ties very heavily into what you would now call UX design. Come from a background in BIM, so building information management, almost 7 years as a BIM coordinator / BIM manager. And now more recently, I've stepped into the computational design space. So if we go through architecture, for those of you that have stalked me on LinkedIn, I used to work at Boertman & Partners, quite a prominent firm here in South Africa. Did quite a lot of retail and commercial architecture, stepped into BIM coordination for commercial architecture, and most of my portfolio was in West Africa. So did a lot of work in South Africa, did a lot of work in West Africa, and I've now moved into computational design in the greater Australia area. While still at Boertman, doing a lot of BIM management. For those of you that know this building, it's based here in Tshwane, Pretoria. It is the Department of Land Reform. It was a project that I worked on quite heavily in the design for manufacture space. So we worked on the facade, and we solved this with visual programming. So stepping into computational design, I wouldn't call it quite computational design yet, but it was quite an interesting project, and it's quite good to see it come out the ground. Then where I am currently, Zutari / Oricon, pretty much dedicated computational designer in the civil engineering space. We do a lot of computational modeling as well. So you'll find Zutari's computational design team has now grown from me on my own. There's 4 of us, and quite a lot of engineers as well. So there's computational design in terms of modeling, computational design in terms of automation, which is quite something I lend a lot of my time to. But there's quite a lot of work we're doing in the engineering space as well. So a little bit of background. This is maybe leaning quite heavily into the research area. Computational design industry awareness. So for those of you that have ever heard of it, there is the Gartner hype curve. And you'll find with any technology, especially things like, AI and generative AI and all those things that are coming out now, is you have a technology trigger and there's a certain amount of hype that builds around it. And you almost find you get a peak of that hype, which is very, very high. It spikes, the interest is everywhere. Everyone's now doing, say, computational design, or everyone's interested in AI. But then what we find is whether it's a barrier to entry or people being more realistic about what it can actually do, you go through a bit of a trough, which we call the trough of disillusionment. And then only after you've gone through that kind of curve do you find actual beneficial change, whether it's in the way you work, in the way your company works, or what you study. But most technology goes through this kind of curve. And we're finding now computational design in industry, especially in engineering, is definitely heading towards that slope of enlightenment where more people are becoming aware of it, more people are becoming aware of what it can actually do. So yeah. This is something that's very close to my heart, especially with how professional work is going to be changing within the coming years. So the basic flow here is, if you think of how architects or how engineers worked, say in the 1960s or the 70s or the 80s, it was really a craft. It was a bespoke work. It's almost an art. But with the rise of the Industrial Revolution and the speed at which we have to work, and especially now the rise of what you can also look up is called Society 5.0 and things like that, we're really seeing a need for not just standardization, but systemizing the way we work, and then eventually externalizing it. So I'll come back to these graphs after my analogy, and they should make a little bit more sense. But something that I focus on quite heavily at work is systemizing something, your solution, your design solution, your modeling solution, in terms of, say, an algorithm, and then standardizing whatever information you're working with, so that it fits into a reworkable model. So this is something we touch on at Zutari quite extensively, is digital transformation, and not just digitizing old ways of working, but actually changing the way you work so that you have an effective change. And what I'm trying to show here is you're going to have increasing moments of finding new work. You're going to systemize that work, and then you're going to automate it. And only after you've automated it do you then scale onto the next thing. So yeah. So I came up with a very simple analogy. Forgive me, I am a new parent. I've just come off of maternity leave. So I've had very, very little sleep in general. And I thought to myself, what's the first thing that you do when you have had very little sleep and you wake up in the morning? You're going to go for a cup of coffee. So you think to yourself, you're going into work, this cup of coffee is great. Everyone should have a cup of coffee before I go into work. So here's your cup of coffee. Works great. So this is an idea of standardizing without systemizing. So you're going to think, I enjoy the cup of coffee, or I enjoy the computational design model, whatever I've developed. Everyone should enjoy it. So there it is on my desk. Let's roll it out to everyone. So here's a bunch of desks. I'm going to say it's customizable. You can put your cup of coffee wherever you like on your desk. It's automated. It's ready for you in the morning. But what a lot of things fall short here then is you get a user that says, well, I don't drink coffee. I drink tea. Or I don't drink any hot beverage. And then how do you design something to both be reusable, but be customizable enough to allow each individual user that uses that model that you've designed in their own way? So here's a cup of coffee, cup of tea. I want options. Enter something like the barista. So if you think of computational design, think of a computational designer within a team as a barista that can make any type of drink for that entire team. So now you have options. You can have tea, you can have coffee, you can have a latte, and it's different every day. I don't drink a cup of coffee every single day. I don't drink the same drink every day. I need to have options. So then you need to be able to design a methodology or a workflow that allows your user their independence and their autonomy, but you need to be able to effectively apply your workflows within that system. And this is where the idea of a barista comes in very well. So you have one person that's very skilled, say, in programming or engineering computations. They can supply a menu to all the users, all the people in their team, and effectively everyone benefits from that. So really silly little analogy, but it helped the non-computational design, non-engineers in my life try and understand a little bit of what I do. So what I like to say is what we do is a way of thinking. It's how we think. It's not necessarily what we do. So if we think in a systemized way, you define what you want to achieve incrementally, but especially important, you define it algorithmically. And after you've done that, you can start to standardize. So if you go back to your barista analogy, is once you've decided I am serving, say, hot drinks, you're going to standardize that in terms of a menu or in terms of a size of a drink or something like that. And then very importantly is once you've standardized and once you've developed your system, you're constantly going to iterate through that so that it improves. You're not going to develop something once. What we like to refer to in our team is the button. You're not going to develop a button that from start to end does an entire process for a person. You're going to constantly provide short bursts of increment of like a workflow that's incrementally better. So yeah. So if we come back to these slides, silly, coming back to the coffee, you're going to have this peak of, I can order anything. There's no menu. There's no set expectation. The expectation is entirely inflated in terms of what I can provide. Then you come back to reality and you go, oh, okay, you can only serve, coffee, a chai, or a tea. But then you go through a slope of enlightenment where as you get to know, say, your favorite barista, they know how you want to make your coffee or how you want your coffee made. So yeah, so coming back to this one, very interestingly, with the analogy here, we're not saying craft disappears. What you do for work or what you do in your professional life is still a craft. But there are ways to standardize that and there are ways to systemize that. So if you think of BIM, for example, there's a lot of push to get ISO 19650 certification, which is a form of standardization. And then eventually you would head towards something called externalization. And the easiest way to think about this is engineering as a service or architecture as a service. And this is basically where you've realized your barista, but now you've taken your barista out of your team, you've put them within the company, and now it's a service that any employee can go pay for. So I can go pay my 20, whatever rand for my cup of coffee, and I get my coffee back. So there's a exchange of service for the service rendered in externalization. I'm going to skip that one. So if we head towards computational design in infrastructure, there's an interesting, we need to distinguish between what architects or what your AEC industry knows in terms of buildings, which we term vertical construction. But then in civil engineering and structural engineering, you also get something called horizontal construction, which is anything such as a road or a rail it's something built over quite a long span of area. And there's a fundamental difference I've realized in terms of thinking that comes from switching from vertical construction into horizontal construction. So if we're looking at horizontal project information, by its nature, it is easily adapted into a data-driven design and modeling tool. Anything along a horizontal project is defined in terms of a line. So this line could be anything. Could be a road, rail, there could be a number of bridges or tunnels involved in this. But graphically, it's developed as say, a simple polyline. And then there's a certain amount of data attached to that. So in civil engineering, we call this an alignment for the architects that are on here. And then an alignment consists of vertical and horizontal geometry. And fundamentally, this object is always data-driven. It's hardly ever driven just purely graphically, which is something in the architecture space that can happen very easily. So this is a space I've really found myself enjoying, coming from working on facades and architecture, as I said, retail and commercial, is switching into civil modeling has really shown me how effective computational design can be when the beginning of your project is already data-driven. So let's go through an example, specifically bridges, because that's mostly what I'm involved in my team. So this is something we've developed called SMART methodology. And what you see on the left is, I think, almost 16 bridges that we developed for a project in the Middle East. And if you look at these little BIM 360 screenshots, they all look slightly different, but they've all been developed with exactly the same code. So we developed a workflow that breaks the engineering of the bridge down into data components, and then that is then expressed, say, graphically in something like Revit. So I'll go through a little bit of the workflow. But to discuss SMART, it's specifically automated. There is a constraint. These are footbridges for the Middle East. It's measurable, reproducible, and accurate. So because all of this is data-driven, there is no manual clicks or anything that you need to do. These are all the heights, all the surface levels and everything is driven by a set of information. It was achievable within an accelerated time frame. We had about 6 weeks to develop this. So from nothing into what the brief was at the time is 20 bridges, which came down to 16. 6 weeks is not a long time. So we decided if there was any hope to make a deadline like that, we had to do this algorithmically. So it was deliberately digital. Everything was delivered digitally. Everything was delivered with what I like to call digital smarts. And then it was time-based version control with iterative deliverables. And an interesting thing we like to bring up is the engineers provided one bridge by mistake. They provided it backwards. So they switched all their data around. And it was quite near the end of the project, about a week or two before it was due. And when we picked up on that, it was maybe 7 minutes to get that back and to get everything updated. So to have a bridge model turn around in 7 minutes or so is really not bad. So this is a little bit of the work behind the scenes. We always say change is a given. So all the data is date stamped. It's stored in one central repository, such as the CDE. And what we actually also developed is something we like to call the stick diagram. So the data you'll see in the middle image is actually the single source of truth. But what we did to ensure that there were no mistakes is we did what you see at the top, which is just a line-based diagram of the data provided. And then what that does at the bottom is then provide, say this was developed in Revit, it divides the actual, the meat on the bones, you could say, of this. So here's a little bit of the workflow for those that want to get into the nitty-gritty. You have an alignment, like I said, because you're working on a horizontal project, usually based in something like a DWG or a land XML, anything that's data-driven. And most of the work happens in, while we're talking in the Autodesk space, it happens in Civil 3D. This is fed through to Dynamo. We develop then something called a JSON file, which is our data-driven control file. This is then reread through Dynamo in Revit, and then the whole BIM space is developed within Revit. So I'd be happy to share more on this if anyone has any questions at the end. So let's follow a little bit the methodology. What we start with is we start with our information. So this will be in your Civil 3D space or your Excel space, or even your Midas space for the engineers on the call. You'll have a horizontal information, you'll have vertical information, which together makes your 3D road. You'll have your bridge location and your engineering intention for the bridge. You'll have in your Revit space your modeling intentions, so all of your abutment types, all of your piers, all of your deck types, all of your beams, everything like that will be developed in Revit. And then what works really well here is your more robust adaptive component families. Then you'll have, say, your Dynamo file, which will pull everything together and do a bit of a sanity check. So you'll see there in the background a bit of that stick diagram I mentioned. And then you'll pull it all together. Let's see if this GIF works. So this part is then automated. So this is where I spent most of my time. You'll have all of this driven through Dynamo again. So you'll have your deck. I think it'll do your railing, and then your topology will also pull through. So this times 16 bridges over 6 weeks in, so a very, very tight project deadline schedule. And it was quite successful. There are all obvious shortcomings. Every time we do this, we learn a little bit. So this was developed the beginning of last year. What we've done since this has increased exponentially. So if we come back to that graph, we've systemized it, we automated it, and then we scaled it. So now we're in the next part of the process of improving this and working on more complex bridge shapes or more complex elevated roads. And then an interesting thing that I might have mentioned is, because this is based on an alignment and it's quite repeatable, the same methodology can be used for tunnels or underground structures. So yeah, that's in a nutshell a little bit of the workflow that we've done. I'm going to open the floor to a Q&A and just say that what I've given you now is a very high-level overview of what we do in our day. But we have actually written a research paper about this that we're now presenting the case studies for at the South African Transport Conference coming up in July. So, yeah.
Thank you so much, Astrid. That was amazing. That was really good. I'm going to open the floor up to for questions, but I'm just going to say a few things first. I mean, I think what you were talking about in the beginning about systemization and standardization is really talking about putting the user at the center of the process, is it not? Right?
Yeah.
So, I mean, I've had a few times where I've developed scripts and I'm expecting everyone to use it. It's like these scripts that maybe create views automatically, and I'm thinking everyone's going to love this, but then no one uses it, right?
Yeah.
It just sits there. But I think you're alluding to one of the problems. You need to continuously iterate
Yeah.
in order to get to use it. Huh.
Yeah.
Um,
Yeah. And
yeah.
something that I found is if you've got a little bit of programming background, or you can think algorithmically, you assume that everyone can. But to make a script usable by your floor that you are working with is quite an art.
Yeah, it is. Indeed. Okay, Theo has a question. It
Yeah.
says, did you need a deep understanding of civil engineering and civil 3D to create this script?
So interestingly enough, I would say no, you don't need a deep understanding of civil engineering necessarily. One of the great things that we found while working on that project is we were, I would say, a team of 4. And while everyone brought their own skills. So I'm coming from an architecture background, I think different to an engineer. So there were 3 other engineers on the project, and then me, architect or instructional designer, whatever you want to call it. And it was easier for me than I thought it would be to switch from architecture to engineering. But having an understanding of civil 3D itself was very beneficial. But it is something you can pick up because it ties into Dynamo. If you know Dynamo in Revit, or Grasshopper in Rhino, the thinking is the same.
Okay. Please feel free to unmute yourself and ask a question if you wanted to. But I'll just ask Astrid another question in the meantime. What advice would you give someone who wanted to get into computational design and do these cool things you're busy doing?
Yeah.
What do they need to do?
No, it's an excellent question. And I've got 2 different answers depending on where you are. So if you're a student and you're, say, studying architecture or engineering, it's beneficial to have some kind of programming knowledge. So whether you're going to take maybe an extra course or do a online course, say in Python, that it's invaluable whether you do computational design or not. I think in this day and age, understanding how to think, how to put a program together is highly beneficial. And then if you're in the workplace, what I would say is just think of everyday tasks that you do, and anything that you do repetitively that's quite easy to define. You can standardize that, and if you can standardize it, you can develop, say, a script or an automation for it. So yeah, that's what I would say.
Okay.
Hi, Astrid. It's Madeleine.
Hey.
Just for interest's sake, you said you took about 6 weeks to model those 16 bridges. How much of that time was spent developing the scripts and the families and getting it all ready without actually having anything to show for it? Before you could complete the model.
Yeah, so that's an excellent question, and it is something you have to discuss with your client, because say you have 6 weeks. For the first 2 weeks, you are not going to have any visual deliverables. You're not going to have any drafting done, because by its nature, you are developing your algorithms first. So in a traditional, say, engineering design / modeling workflow, you're going to have clients that want to see drafting, and they're going to want to mark up drafting. So it is a little different, and there is a little bit of, you need to stand firm and say, this is the way we're doing it. You need to give me these 2 or 3 weeks. But then after that, you will see an exponential improvement in terms of visual deliverables that you can then, whatever you want to mark up or something like that. So yeah.
Yeah, it's hard to convince clients to go that way and to allow us to do computational design, because they don't see the results immediately, and it's hard to convince them that it's actually a good way to go. But thank
Yeah.
you. Thank you for your answer.
Perfect. No, in this instance, because the time frame was so short, we wouldn't have been able to make that deadline any other way.
Yeah.
So there was a little bit of give and take there, which was nice. Yeah.
Thanks.
I mean, that was going to be my follow-up question from Madeline's question. Like, how do you convince a client that this is a good idea? I mean, in firms, we still struggle to convince people that BIM is the right way to go, you know? So, yeah, but thanks for that. Any other questions, please? Okay, you can unmute yourself and ask.
Hi, Astrid. I just have two questions. The deliverable, was that like concept design, or was that like a full like detailed design? Did you submit like a set of drawings, or was it just conceptual models that you submitted to the client?
So that's a good question. If my memory serves me correct, it was 100% conceptual design. So they weren't construction drawings. They weren't issued for construction, but they were drawing deliverables. So it wasn't just say a BIM deliverable. There was a bit of drafting work that had to happen as well, but we provided as much as we could within the BIM space, and then there was a little bit of manual work after that in terms of getting it presentable on a sheet.
Thanks. And your paper, is it still going to be published, or have you already published it? The one that you got on the screen.
It's been approved. I think it will be published after the conference concludes. Yeah.
Okay. Thanks.
Sure.
Hi, can you guys hear me?
Yeah.
Okay. You mentioned earlier that it's beneficial to learn a programming language, and you mentioned Python. Is it better to have a deep understanding of one language like Python, or is it better to have like a surface level understanding of all of the languages?
So, good question. My answer would be it is a good thing to have an understanding of thinking algorithmically. So you'll find once you learn C#, Python, Java, so if Python's more a scripting language and C# and Java are more programming languages, they think the same way. The syntax might be different and one might be a bit more complex to, get up and running, but algorithmically, you're thinking through logical steps. So you don't even need to learn a programming language to think that way. But what I would say is, if you are looking at learning a language, decide whether you want to go into, say, because we're not software engineers, we're not developing, apps and programs that we are then selling. We are working in an engineering space, and our deliverables are still built objects in the real world. So for me, scripting is the way to go, but it might not be the solution for everyone.
Awesome. Thank you so much.
Okay, any other questions? Emma, please, you can unmute yourself and ask the question.
Hi, Astrid. I'm just wondering how often you find that manual intervention does creep in. And do you think it's ever possible to eliminate manual intervention completely, or is it completely dependent?
So that's a good question. And it's touching on that. Okay, so this is something we touch on in our paper called human in the loop automation. And something that we believe in our team is you don't ever want a program or a computer to do everything for you from step one to the end, because then what is the point of you sitting in your chair almost? So I don't think any real built elements, so buildings, bridges, tunnels, will ever be designed 100% by a computer. You will always have a certain amount of manual intervention or a certain amount of manual checking, for example. But a lot of what we do at the moment, such as drafting or modeling, can be automated so that we can model and draft and engineer better, not to take that away from us, just to improve the way that we work.
Great answer. Thank you.
Thank you, Astrid. I think I'm going to leave it there unless you're fine to answer more questions.
Oh, it's fine.
Okay. Anyone else have a question? Okay.
Hey, I was going to just ask a quick one. Just in
Yes.
terms of fabrication, naturally you're more on the engineering side. I just find that having been in the industry for a long time, I'm just getting really bored of brickwork details and plaster that's not flush and all that. And I'd love to do a building where we CNC cut all the components and everything fits together perfectly. Do you do any work like that? Or are there like architects or engineers in the country that's sort of exploring that at the moment? And maybe just to complete the question, I know Earthwalk Architects did that little coffee shop in Menlyn, I think it is.
Yep.
And so there's little things bubbling up, but you know, I'd love to see more of that and hopefully and potentially get more involved in something like that. Yeah.
Yeah, it's a good question, and it's a good observation as well that, you know, if you're in industry for an extended period of time, doing the same thing over and over, you do get bored of it. So it's a very good observation, and definitely there is space within not just industry, but if you look at the tertiary education, such as UP at the moment, they're especially in alternative building materials. So if you go into timber or CLT, there's a lot happening in that space. So between the engineering and the architecture departments at UP, there's some exciting stuff happening there. And then also in industry, there is a company, if you go check out their LinkedIn post, MTT, so Mass Timber Technologies, they're part of the Sustainable group. They just got a 6-axis robot. So they develop CLT panels for architects or anyone that's using that as a building material, and that's a very exciting space to be working in. So if you're working with a company that is so forward thinking in terms of the technology that they use, and in terms of, you know, if you're going to take as much as you can into prefabrication or pre-drilling, things like that, then that's one to watch. So yeah, I hope that answers your question a little bit.
Yeah, no, it does, and I am following those people as well. I'm just wondering how many projects are actually being delivered or developed at the moment. But I mean, I'll chat to them as well. Yes, yeah.
AJ, there's also Raw Studios.
Yeah.
So we're working with, actually at C at the moment, we're getting the students into Grasshopper and prototyping and CNC cutting. The plan is to get them to fly up to Joburg. We'll see if that actually happens. And actually, they go to Raw Studios and fabricate their projects. So you should speak to them as well.
Awesome. Thank you.
Yeah.
Thanks a lot.
Yeah. Anyone else? And if there's no other question, we will be able to close. But just put up your hand if you want to ask a question. Okay, no other questions. Thank you so much, Astrid. We really appreciate your time. This was a really amazing presentation. I've definitely learned a lot from this. And yeah, thank you so much. Have a nice weekend.
It's a pleasure. Thank you for having me.
Thank you. Cheers.